Welcome to everyone who's signed in today. Thank you for joining our webinar, Overcoming Physical and Cybersecurity Threats. Today we have two speakers who will be presenting. First, Dave Lathrop, VP Utility Strategic Business at Unlimited Technology. I've known Dave for over 7 years now. Prior to joining UTI earlier this year, I watched Dave lead Avangrid US, which was formerly the Iberdrola system in the Northeast, and he led them through a massive technology upgrade. As part of that, I watched him establish risk profiles that senior executives could understand. He then took that and built designs with a cost basis that matched those risk profiles. But probably most amazing from my observations, he served as the technologist who brought together over 40 separate vendors from hardware, cybersecurity, access control, VMS, and video analytics to build a system that now serves multiple utility operating companies across multiple states in the United States. It was quite an amazing accomplishment. So Dave's a guy who can speak at the executive level, but can also go down and really get down into the weeds and understanding how technology applies to different risks and system designs. Following Dave, we will have Svika Shani, Chief Technology Officer of Agent VI. Svika is well known to the video analytics world. In 2003, he founded Agent VI, where he still serves as our Chief Technology Officer. He's a frequent speaker and writer on two subjects related to video analytics. First, the introduction of AI methods to enhance the performance of video analytics. Agent VI was one of the first companies now almost 6 years ago to begin introducing AI technologies into our video analytics platform. And secondly, he's become an expert on new hardware and architecture designs that are required to support these AI methods. They really don't work the same way the old analytics work, and you have to start thinking about hardware and architecture in different ways. Before we start, a few housekeeping notes. We will not take live questions during the presentation today. However, if you look at the bottom of your screen, you can see a Q&A box. Please submit questions, and during the last 10 minutes of the webinar, we will answer as many questions as we have time. With that, I'll turn the presentation over to Dave and let him get started. 1 second, Dave, it's coming at you.
Thanks, AJ. I think that worked. I'm now sharing the PowerPoint. Is that correct? Can you see that?
Yes, we see you, Dave. It can be lonely in the Zoom world on the other side of the wire, but we see your presentation now.
Yep. Okay. Thanks. Okay. So today I'm going to present risk-based security in regards to design and security program that includes cybersecurity, NIST-based cybersecurity controls, and AI-powered video analytics. Before we get started, as AJ said, I retired from the utility space after 30 years of working at Avangrid. Started there when it was RG&E, moved to Energy East, then Iberdrola, and then Avangrid was formed, where I finished my career there. Unlimited Technology hired me to support the already established cybersecurity vertical that the company has. We've been in business for 30 years. We do about 100 million a year in revenue. We currently have over 160 full-time employees. We also offer professional services, staffing placements for IT and OT shops. We have a number of verticals within the company, including a program called Xero, which is a health-based maintenance monitoring system, which I'm going to talk about throughout this presentation a little bit in regards to endpoint visibility and monitoring of all assets on an infrastructure, whether you build it new or you're taking over an existing. It gives you endpoint to endpoint visibility to all those assets, which is critical in the cybersecurity world. So to get started, we'll talk about risk-based management frameworks. Infrastructure design and risk management frameworks must be holistic in approach, including the end goal and cost to reach that goal. Think of it as risk versus cost over time. Endpoint design down to the video and access control system, edge devices, must include a tier-based risk classification per location tied to a security system design level or type. And I'm going to cover the tier-based approach in a future slide. But before we start to talk about the tier structures that you would need to build a program, I want to talk a little bit about the current cybersecurity world and what we're all facing for all infrastructures, whether it's banking, utilities, you name it. If you have an infrastructure that is IoT based or air gapped and internal to an organization, this is a risk that you need to be aware of when you develop a program, whether it's just for physical security or if it's a complete infrastructure build, meaning transport network and data centers. So the data points in this graph are the slope of attacks and also the cost worldwide of cybersecurity. And you'll see that the sheer number of attacks and the cost of cybersecurity worldwide is going through the roof. We're here, we're in the heel of the hockey stick. This is not an issue that we're all going to experience 10 years out or 5 years out. It's happening now. We started to plot these graphs back in 2014, and what we were really looking for was the angle of slope when we measured the cost worldwide of cybersecurity against the sheer number of attacks. And when we did this, we found that the angle of these two slopes matched, which strengthened our belief that machine-on-machine learning in the hands of the bad guys was what was really driving the sheer number of attacks and driving these numbers up exponentially. We're on target this year worldwide to hit cybercrime levels at $2 trillion, next year $6 trillion, and the following year $8 trillion. Think about that, $8 trillion in cybercrime. That's going to impact all of us. The reason we believe that this is going to impact all of us is because we measured it against the NIST 800-53 series controls, which roughly, with subfamilies included, there's 640 controls. The average transport and data center network security controls in place in the industry for critical infrastructure is 140 controls, and that is flatlined. So this worked and was effective all the way up until about 2014, when the risk and the sheer number of attacks due to machine-on-machine learning being in the hands of the bad guys started to pass over that threshold. So if that stays flatlined and you're living in this space down at 130, 140 controls in place, and the risks are growing exponentially, you're going to find yourself in trouble in the next couple of years. So when you talk about a risk management framework and you start to develop a design methodology, you want to understand this risk. The example that I would give of this risk is machine-on-machine learning toolkits are now available on the dark web. I could go online and buy for about $2,500 a machine-on-machine learning toolkit that would allow me, one bad actor, to orchestrate large-scale attacks against any company I wanted to. In the past, this used to only be accomplished by nation states and large organizations that employed many IT professionals that could orchestrate attacks. But now, with machine-on-machine learning out there, it's really changing the attack vector and the defense vector of cybersecurity worldwide. So what's this mean? This means that AI and asset management tools, so you have full transparency and full visibility into who's on your network, what's on your network, and what's happening on your network all of the time in real time, are a must-have. So again, when you move into the design methodology phase of a program, you want to take this into account and be aware of it. This graph and these data points represent that by 2022, we're going to enter into a new phase where firewalls and reactive-based defense systems that are in place now are still definitely going to be needed. But in addition to that, if infrastructures don't deploy AI-based defense and full visibility to all assets attached to their network, they're going to be in trouble. That's what these data points are showing us. So next, I'm going to talk about adopting a design methodology. And in doing this, you want to include innovation and automation in your thought process. On this slide, the pictogram here on the left side represents a decentralized transport network or design of a security system. And on the right-hand side represents a centralized design or a mesh network. So as I talk through each one of these bullets, keep in mind that on one side is decentralized and the other side is centralized. This is probably the most important decision you would make when you're developing your design methodology, because a centralized system costs a lot more than a decentralized system. Most people inherit a decentralized system because it's evolved through the years. You started off with guards at each location with CCTV systems that then were changed over to NVRs and centralized back to operationally a security ops center to monitor all of your video from one location, while you still had a decentralized design, meaning all your computing power was out on the edge. That affects your reliability and redundancy. So in my case, an example I would give of the decision around centralized and decentralized was when we made the decision to centralize, we were able to eliminate over 20 guards at 20 different locations monitoring thousands of cameras back to one security ops center and a total shift 24/7 of a staff of 6. The reason we were able to do this on the security side was because of the Agent VI product. Our scores and our testing showed that their video analytic, and this is 6 years ago, was coming in at plus 95% accuracy. So what that did for us is it allowed us to, with 2 guards per shift, to monitor up to 4,000 cameras at one time, because the guards didn't have to watch all the cameras all of the time. The analytic would wake up the camera and tell the guard, this is something you want to look at. And we had feedback into that loop where the guards would then say, this is a false positive or this is a positive alarm. So we were able to track and trend the accuracy of the algorithm that Agent VI was providing us. And it was extremely high compared to the tests that we did with other video analytic systems. This was effective in reducing O&M for yearly cost of supporting large guard staffs and centralizing. The next step in that process for us in the centralization was to move data centers into a centralized design where we had mesh networks that were redundant, so that if one fiber cable broke, we wouldn't lose the transport data to the location or visibility of the location on the cyber side. It was all about redundancy and reliability. Again, bullet 3 talks about endpoint visibility. I can't stress it enough, whether it's physical security or IT infrastructure. When you build a centralized or decentralized model, you want to make sure you deploy tool sets like Agent VI that give you full visibility into all the assets and underpinning assets that support that infrastructure. If your IT network goes down, all your cameras go down. So you want to make sure that that IT network is healthy. The next step in the process is to build a tier structure. What we did at Avangrid is we classified all of the locations that were in our scope into 4 different tiers. Tier 1 being the most critical tier, where we deployed thermal cameras, daylight cameras, and really the highest number of security endpoint devices to protect that substation in this case. So what we did was, we followed a methodology of defense in depth when it came to the physical security design. We used video analytics looking outward from the substation to extend response time. In our case, we were using the Agent VI platform to recognize anything with a motor or anything with a heartbeat. So if any vehicle of any sort approached the substation, the analytic would wake up the camera back at the security ops center and tell the guard, this is something you need to look at. Same was true for a heartbeat. This was highly effective in our design because in most cases, we were able to call the police and get them to the location and stop whoever was trying to break in, whether it was vandalism or copper theft or something of a malicious nature at a higher level. This was effective because we were extending response times up to 30 minutes before they actually cut through the fence and tried to get into the substation. So in most cases, the police would arrive before any real damage was done to our infrastructures. So as we added to these tier structures at tier 2, 3, and 4, we then classified and came up with a base design that would change a little bit per location within that tier. But we classified the tier structures into a value. So tier 1 cost to install and deploy was roughly $300K in regards to video analytics and access management. Tier 2 was 200, tier 3 was 150K, and tier 4 was lock and key storage facilities and buildings that, based on our risk modeling, didn't really provide a high level of risk, so lock and key was acceptable. Once we had done that, this drove the overall corporate risk down with a tier structure based on risk appetite, meaning we tied those values to the asset value within each tier structure. So in this model on this slide, what I'm showing is that we were addressing $9.4 billion in total assets, and the security spend to protect all those assets was 0.5% of that $9.4 billion, or $58.3 million over 6 years, equaling $9.7 million per year. So we developed a project plan over 6 years to reduce the risk to the overall corporation for a very reasonable amount of money. And it was my experience, because I had already been deploying physical security systems for quite some time, that 300K and these values were real values that were obtainable. And this really allowed us to build a spend based on total asset value and include a risk model in our decision making. So this was an effective tool to take to the board and the senior team and lay out a 6-year plan to obtain budgets to achieve our goals. So when you have your plan and your budget, the last step is to partner with world-class companies, which we did. We partnered with Agent VI. We partnered with, in the last 6 years, the partnership included an AI, which was the IronNet product, Iron Defense, and a health-based maintenance platform, which was the Xero product that we talked about. And in doing this, we were able to achieve a massive build-out in a very short period of time that the budget supported across the whole Northeast of the United States. Ultimately, what we did is we built a huge infrastructure that was cyber secure, that used computing centralized, so it was easy to manage, and it provided real-time incident response because of the visibility. So one of the major factors in this project for the physical security side of things was Agent VI. And my experience with Agent VI is that they showed up 100% of the time. They were there whenever we needed them. Whenever we picked up the phone, they either sent somebody to our location or remotely were able to support us in achieving our goals. The testing that we did against the analytic systems that we compared Agent VI to, they didn't compare. Most of them came in with outside cameras at 80% accuracy, where Agent VI consistently provided 95 to 98% accuracy on what we were looking for in snow, rain, fog, all kinds of weather conditions. It really is a great product that out of all of the products that we integrated into the infrastructure we built, it's probably the easiest company to deal with and easiest product to integrate. Very successful program in regards to the physical security side of things. So at this point, I typically take questions, but I think that we're going to do that at the end of this presentation. So from here, I turn it over to Zvika to talk about the actual product and the AI that is provided by Agent VI.
Thanks, Dave. Let me just get my screen up there. Okay, hi everybody. I'm Tzvika Ashani. I'm the CTO for Agent VI. And during the next 20 minutes, I'll be talking about our new video analytics platform called Innovi. We'll discuss various applications that the platform supports, and then we'll end with a live demo of some of the features that we have. So a few words about Agent VI. We've been around since 2003, focusing exclusively on developing video analytics capabilities for surveillance. We're now at our third product technology iteration, implementing AI and distributed processing, both in customer hosted environments and in the cloud. We have deployments all over the world with various verticals, including utilities, smart cities, private enterprises, and small businesses. Our products have been integrated with a lot of the leading vendors in our space, both camera manufacturers, video management systems, and other types of software and components used within video surveillance. So I want to start by talking a bit about how we integrated AI into our video analytics pipeline. This is a process that we started about 5 years ago, and we were actually the first to market in our space with a production system that utilizes AI. And basically what we're doing with AI, we're enabling our solution to be both much more accurate in terms of distinguishing between real interesting objects such as people, vehicles, and other types of objects, and noise. And noise in outdoor environments can come from a variety of sources, both from weather conditions, insects, rain, and so on. So having a reliable video analytics solution in such an environment is not an easy task. And this is where AI comes in. We've been able to build very, very accurate deep learning based models that allow us to detect objects of interest. We've trained our system with about 15 different types of objects and distinguish between them and anything that's not interesting. And this really allows us to provide a solution to our customers that right out of the box is going to be very accurate on any camera that's connected, and also will not require any tweaking or maintenance from the user. So AI really allowed us to get to the next level with the quality of the product. And as I said, we were first to market with this a few years ago. And since then, we've been continuously developing it and adding additional capabilities. Our models and our system works on both visible light cameras and also on thermal cameras. We usually find customers using thermal cameras in the long range perimeter protection, and usually with higher value assets where this type of accuracy and distance is required. So looking at some of the applications that we provide with Innovi, real-time event detection. Basically, that's the ability to turn the camera into a smart sensor. You can configure each camera with any number of detection rules, which will analyze the behavior of different types of objects, people, vehicles, and also different types of stationary objects. And whenever a rule violation is detected, we trigger an event in real time. That event is sent usually to a third-party monitoring solution, and then usually have somebody responding to that event. Another application that we have, and this is also a real-time application, is anomaly detection. So with anomaly detection, you don't really know what you're looking for in advance, but you want the system to make you aware of any unusual occurrence on any camera. So what we're doing here is we're actually collecting data on the objects and their behavior on each and every camera. And then we're using machine learning to build the detection models based on that data. And then we can apply those models in real time to detect any behavior that's anomalous, and again, trigger an event in real time and send it to an operator. Video investigation is another capability that we have. And here, you're not actually using the system in real time, but you're looking for an event that happened in the past, and the past can be 5 minutes ago, it can also be a month ago. And what this capability allows you is to really zoom in on the relevant video recordings out of large numbers of cameras and extensive periods of time, and do that very quickly by specifying targeted queries. And we'll see an example of how this works. And finally, operational insights. Since our system is continuously collecting data from all of the cameras, that data can be turned into statistics and then be used for different types of operational improvements. So we can generate statistics on people traffic, on vehicle traffic, speed analysis, different types of applications that are not strictly event-driven, but do enable our customers to generate additional value from their existing CCTV installation. So how does the system actually work? Basically, we have two components. We have Innovi Edge, which is a device that sits on the customer's local network, and through that network connects to their cameras and processes them. And then we have Innovi Core, which is our back-end processing, where we set up and configure the system. We monitor the health of all of our devices. We receive all of the events, and then we propagate them, and we do other types of analysis. Innovi Core comes in two flavors. The first flavor is as a SaaS component. Basically, it's a service that we as Agent VI run, and then our customers simply need to install one or more Innovi Edge devices in their locations, connect those devices to our service running in the cloud, and then they're good to go. So it's a very, very quick way of setting up the system with minimal to no maintenance requirements from the user. For those who can't work with a public cloud, we are able to take Innovi Core and basically deploy it in the customer's data center. All of the functionality is the same, but the customer is then responsible for maintaining the hardware and software platform. The way that data actually propagates through the system, we start with an IP camera. The IP camera sends an RTSP stream to our edge device. The edge device will decode that stream and then run our video analytics pipeline at the edge. So this means that we don't need to upload the video to the cloud in order to process it. All of the pixel level processing is done at the edge. We detect objects, we track them, we create metadata and events, and then only the metadata and events are propagated to Innovi Core. And again, as I said, Innovi Core will store that data, we'll do some additional analysis, and then we'll send it out through our API to any system that wants to retrieve that data. A few words about cybersecurity. Because our solution is designed to be both SaaS-based and on-prem, we needed to very carefully look during the design stage at all the different points of vulnerability when we will be connecting devices from local networks to the cloud. And we employed several strategies in order to ensure maximum security. All communication, of course, is encrypted. We don't require any manipulation of local ports or firewalls at the edge, since we're only doing outgoing communication from the device to the cloud. We're using role-based access control. So that means that we are able to control at a granular level which data is accessed both by customers and by Agent VI employees. We maintain extensive audit logs for any action made by the user. And we harden our edge devices using IT best practices in order to minimize the risk of an edge device being compromised by a local attack. So I'm going to switch to the demo. 1 second. Okay, so what we're looking at right now is the Innovi dashboard running in a standard browser. And basically the Innovi dashboard or portal has several modes of operation. The administrator mode is used for setting up, configuring, and maintaining the solution. The monitor tab allows us to actually monitor events in real time. And the investigation tab allows us to run investigations. The system does support placing your cameras on a map. And if you decide to do that, then we're able to show you both the location of the cameras and also the actual location of the events and objects as they're seen on a map. Over here on the left, we have our deployment hierarchy. Normally, you would divide this by a physical location. And in each of these locations, you will normally have one or more physical device. So here you can see an actual representation of the device itself, and each device can have multiple cameras connected to it. And if we drill down into a specific camera, what we're seeing right now is the camera dashboard. And the camera dashboard gives me a quick overview of what's happening with that camera, including seeing a live view of the camera. Down here on the left, seeing a list of rules that were set up for that camera, getting an overview of the event stream generated from that camera. And from here, I can also go in and create rules. So going in to create a rule is quite simple. We select a rule type. For example, an occupancy rule. We set up a zone for that rule. We can specify other parameters such as number of people, dwell time, and basically we're done. We save that rule, and then it immediately goes into effect. Looking at the monitor, we'll go to the top level. So here we can actually get an overview of the events generated. Right now I'm looking at the top level, so I'm seeing all events from all cameras. We can of course filter to see only events from a specific camera or a specific folder. Each incoming event is going to be represented by a thumbnail focused on the object that generated that event, and also a timestamp and a description of what that event actually is. I can obviously double click on that and see a short clip a few seconds before and after the event. And basically, we provide this interface as a monitoring interface, but in a lot of cases, our customers are actually ingesting the events through an API and then using their own monitoring application for handling them. Next, we'll take a look at the investigation module. As I mentioned, with investigation, You don't need to set up any rules in advance. What we're actually doing is we're processing all of the video in real time and converting it into that metadata, into metadata. The metadata is stored in a database. And then whenever you actually want to find something, then we can just search the metadata. We don't have to go back and analyze the source video. So this means that the actual process of searching is very, very quick. We can go through large numbers of cameras, covering large periods of time in literally a few seconds, up to a few minutes if the query is very big. So the search starts with selecting the cameras that you want to search on. Again, you can use the map and highlight an area on the map that you want to search, or you can go back to your site hierarchy and select a camera. So in this case, we'll just leave all of the cameras selected. Next, we can select a behavior that we're looking for. So we'll just be looking for people moving about. Next, we'll specify the type of object. And in addition to specifying the type of object, which can be a person, it can be any generic vehicle or a subtype of a vehicle, and it can also be a two-wheeled vehicle. So in addition to the vehicle type, we're also able to specify colors. So if for a person, I can select an upper body color, which is red, and let's say a dark or black lower body color. And finally, we'll select the time range that we're looking at. So we'll do a query on the past hour. And now we simply have to hit the search button. And you can see the results that we're getting. So we were looking for people with a red top and a dark bottom on all of our cameras. And you can see the instantaneous results that we're getting there. And again, we're viewing the results here in a thumbnail view. We can click on any thumbnail, see the recording a few seconds before, a few seconds after, and really understand what happened with that event. It's also possible to see these results on the map, assuming that you have registered your cameras on the map. So we can see how these results were laid out on the map, and we can zoom in, for example, in this area. And again, depending on your application, the map tool may or may not be relevant to you. Usually with our customers that have larger, more dispersed systems, it's a really great integration between having the analytic and the view on the video and understanding the exact location of that event on the map. And finally, we have a report section. And basically, the report section will allow us to generate the, or export the statistics data that I mentioned. You will select the cameras that you want to export the data from, select the time range, and then we'll provide that data in an Excel format that you can then import into whatever BI tool that you're using and continue from there. So to wrap things up, Agent VI has quite extensive experience in the analytics industry. Innovi as a platform will offer you a robust feature set. So whatever you need to do with cameras, whether it's perimeter protection or within a city, detecting events and doing investigations or generating statistical data, you can do all that with a single platform. And basically all of these capabilities are available at your fingertips. Innovi is available both as a cloud SaaS and as an on-prem deployment. I didn't really get into this, but in terms of the hardware costs, we've invested a lot of effort in minimizing and optimizing the way that we use edge devices. So we have the lowest hardware cost per camera for video analytics, meaning that your additional investment in hardware required to run Innovia is going to be minimal. High accuracy, search results, we talk about all that. In terms of scalability, again, if you're using our cloud platform, you can start with just a few cameras and grow to systems of tens of thousands of cameras and never worry about scaling your back end. You're always going to have the required storage and processing power available. Federated by design, whether you have all of your video coming into a central location or if you're working in a distributed environment, Innovia is going to fit your network architecture very naturally and easily, and it will be quite quick to deploy it, whatever architecture that you're using. And with that, I'll hand it back over to AJ, and we'll see if there are any questions we should answer.
All right, great. Thank you, Svika and Dave. So yes, there are some questions. I'm going to go ahead and divide them up as I think appropriate between each of you, although you're both willing to, welcome to comment if you think it's appropriate. So Dave, let me start off with you. On the UTI, so does UTI just do the kind of design consulting work that you were presenting, or does UTI also implement and build these kind of systems?
Yeah, that's a good question. We offer turnkey solutions, so design and implementation, project management, cradle to grave is what we offer. So it is a holistic approach through UTI from cradle to grave.
Okay, very good. All right, actually, maybe I'll divide these up so neither of you go to sleep. So Svika, actually, I think you were probably starting to touch on this on the end, but if somebody has older hardware servers, do they need to add GPU cards into them? There's been a lot of discussion about the new AI analytics and the requirement for GPU enabled cards. How does somebody deal with it if they have existing servers?
Right. So actually, our edge devices do not rely on GPUs for processing. We've done a lot of work with Intel on optimizing our AI engine to run directly on Intel processors. So if you have existing servers that have processors from, let's say, the last 3 to 4 years, you should be able to run our software on those servers. And of course, you're going to get varying results in terms of the camera capacity or how many cameras you can run per server, but you will be able to use that existing hardware without needing to drop in any additional stuff like a GPU.
Okay, great. All right, back to you, Dave. A pretty open-ended question. Maybe you can put your Avangrid hat back on for a second. Somebody who is taking over an existing system, maybe a large system you alluded to, is probably built with DVRs, might have different versions of software running at different sites. How would you recommend they get started? I mean, how do you kind of start tackling that? Because obviously very few people are starting from scratch. They're usually taking something over, as you even alluded to. So how do they get started if they have one of these old, very distributed designs?
Well, the first thing is to, understand and catalog all of the assets and software applications that you have out there, so you know how many different platforms you're dealing with. If it's really 1 or 6, that matters. Use the process and the PowerPoint that I just went through to come up with a design methodology and a process, including all of the requirements that regulatory requirements that may impact whatever industry it is, and really have that design methodology applied across the board, to the approach. for what type of network, transport, data center, and edge devices that you want your end goal to be, and build a project and program around that. Centralization and standardization generally are the direction that I went in, meaning when we started with our video analytic systems and video systems out there, it's been a while. I think we either had 4 or 5 different video systems that we first migrated to one video platform, and then we migrated to a centralized platform.
Okay, so you're saying you actually kind of took that in passes. You didn't just come in and say, all right, throw everything out, let's go to the end goal. You had to actually kind of tackle it in a couple waves.
Right, so it's a phased approach because they were operational, and I'm assuming that whoever's asking this question has some sort of operational need where all of the disparate systems that are out there now are serving. So exactly, you can't just turn it all off and start from scratch, because it might take you a year or 2 to get everything standardized and cut back online. So what we did is, the first approach was to take the 5 systems. We agreed on one platform through our testing. In that case, for video analytics, it happened to be Agent VI. I think at the time we were using Milestone as a VMS also. Then we took the approach of getting rid of Panasonic, Sony, and a whole host of other video systems that were out there, Pelco systems. And we standardized across the board to one platform. Once we had all NVRs on one platform, so it was really only like a day downtime for each site, then we were able to start to aggregate all that information and standardize back to a centralized approach. So it was a 2-phased approach, first to standardize on the edge, and then to move all the computing on the edge to the centralized design.
All right, I'm going to hit you with another corollary question here. So looking at your bio, the 325 million, wow, that's pretty impressive. But what about utilities or other critical managers of critical assets that don't have $300 million plus budgets to work from? Any moral support or coaching you can give them on how to get started? Because that seems like a pretty big number to get.
That, sure. So yeah, that's a massive number. And the reason that number is so big is because it involved the build out of some pretty high-end data centers, as well as a massive transport network across the Northeast of the United States. At any scale, if you follow the tier-based approach and apply the budget that you have to that approach, once you categorize all of your assets, meaning locations, into a tier structure, you can build out what the cost is going to be. If you're say your project is only to go after a video management platform, you can build out those costs and then stretch it out over time. It may be a 3-year project, it may be an 8-year project based on your budget. So scope, schedule, and cost can be controlled by using that tier-based approach and categorizing each location, and then applying a cost to each tier to obtain budget dollars.
Okay. All right. So I'm hearing. So what you're saying is you don't have to divide those tiers by 300 million. You could, even if you have much smaller budget, you could take the same approach. You're just going to have smaller chunks at each tier that you can afford to address.
Exactly. Exactly. When you look at your assets, so that made sense in the Avangrid world, because a bulk power substation is valued at over $60 million to replace. So if you are working within a company that you're protecting shipping containers, you may have a location that only has $100,000 worth of assets. You're certainly not going to spend $300,000 on a security system to protect $100,000 in assets. You might only spend a couple $1,000s and put in 2 or 3 cameras.
Okay. All right, Sika, back to you. This question is sort of a cynical question. So, are these AI based analytics really better? I've been burned before.
Okay, so always when you ask if something is better, you need to compare it to something else. But if we just compare it to our own previous product, which was also a leading product in the pre-AI era, then we are seeing a very significant improvement in both detection accuracy and false alarm rate, and also in our ability to provide additional features that we couldn't provide before. So because of the ability to detect and classify much more accurately, so when we see that something is a vehicle, we can know if it's a bus or a truck or a pickup truck, and then expose that information to the user, allowing him to create much finer controls over what does generate an alert and what doesn't. And again, the reason that we can do that is because of AI. So yes, there is a significant improvement. And I can understand where the question is coming from, because there are a lot of products out there claiming to use AI, but they really lack the depth and experience that Agent VI brought into our application of AI, which allows us to reach the levels of performance that we have.
So AJ, this is Dave. I can share a little bit of how we came to the conclusion that Agent VI through our testing was 95 to 98% accurate on outside cameras. So we had a full-scale test lab at one of our facilities that we set up when we were doing the analysis and compare of analytics that we were going to build into our system. And most of the analytics, when you look at indoor cameras, motion detection and analytics, alarming, is pretty comparable because it's indoors and the environment is pretty consistent. It's the outdoor cameras where we really had the problem. And a few percentage difference, 5% difference, makes a big difference when you're talking about 4,000 cameras alarming in a rainstorm, all going back to a centralized security ops center. They get flooded with false alarms. So it was important to us that we tested this, which we did do. And my experience in those tests, when we compared other analytic systems to Agent VI, was they were really light years ahead of, at the time, which was a number of years ago, they were light years ahead of all of the other analytics that were out there, percentage-wise on positive alarms. So my experience in that, to answer that question, is we did do quite a bit of testing before we pulled the trigger on moving forward with Agent VI. You know, it was real testing on real cameras and real outdoor environments, rain, snow, fog. So we had some real good data when we made that decision, for whatever it's worth.
Okay, well, thanks. Appreciate that. And I think with that, we've addressed most of the typical questions here today. If you were interested in more information on Agent VI or UTI and what Dave is doing, you can feel free to contact us. We can get you in touch with Dave or somebody at UTI if Dave's not the right person. If you're also interested in learning more about Agent VI and our new platform, Innovi, or I guess now it's not new, it's a 5-year-old analytics platform, Innovi, you can contact your salesperson, or again, you can just contact us at sales@agentvi, and we'll be happy to connect you with somebody. And also, this session is being recorded, so if you would like to refer it to somebody that you think it would be beneficial or helpful for them to hear, it is recorded, so it's available for those who may want to listen afterwards. So as usual, we know that your time is valuable, and we appreciate everybody's willingness to sign in today. And with that, I'm going to go ahead and close out the session and say again, thank you to Dave and Svika for great presentation. I hope everyone has a good day and look forward to talking to you again. Bye-bye.